will see some of the object-oriented aspects of Java. And first of all, we will see what are classes and how we can declare classes in Java and how we can use classes in Java. So first of all, what is a class? You may have noticed that whenever we have created our first program, it was a class, and inside this class we were calling this main method. So every Java project has at least one class and one main method. And class is basically a data structure or type inside which you can define some variables which are called member variables and methods which are called member methods. And the most important property of classes are you can create instance or object from class, so you can maintain different states of a class using these instances or objects. So let's see how we can define a class, which will be a new class, and how we can use it with our main class, which is my class. So for example, we want to make some student data structure, and for that we will make a class. So just go to your project if you are using Eclipse and go to the package you have made. We have made a lesson 1 package at the starting of this video series. Go to that package inside which you will be having a class, my class in my case. Just go to the package, right click the same package and go to new and create a new class. And this class name, we will name it as student. Okay, and leave everything as default and click finish. And now we have this student class inside our lesson 1 package. So we have two classes now. My class is the first class which we were working on, and the second class is called student.java, and this is the second class we have created now. Now this class can have its member variables and methods. So for example, what can be the traits of the student? Student can have his ID. So ID is integer value, so I declare a variable called ID. Student can have name, so I declare a variable called name. And student can have age, his age, so I declare student age. Okay, so this is basically you have created a class, and it can have member variables. It can also have member methods that we will see in a moment, but let's consider this is a basic student class which contains 3 variables: ID, name and age. Okay, now to call this class in your main method in my class, you can just create an instance of or object of the class. So how you can do it? You can just call the same name, student class name. Just copy this name here and then give the name to your instance. So as we give any name to our variables, for example age, name or something, here also you can give the name to the student's variable. Okay, so for example the name is Mark. We are making the data structure for Mark is equal to new student. Okay, and this basically we have created an instance of student class which we name as Mark. So this is a Mark instance. So Mark here is called object. Okay, or some people also call it as instance. instance. Okay, instance. So mark is here called the object or instance, and this object we can use to assign values to the member variables of this student class. For example, marks id is so whenever you call this instance called mark, and whenever you use this dot separator, it will give you the options which is provided by Eclipse to you. So the student class contain age, id and name. So we will choose id. Student id is equal to, for example, 1. Mark is our first student, and in the same way you can call mark dot name, should be mark dot name is equal to, name is mark, we already know, and the age. So mark dot age is equal to, and he is 15-year-old, for example. So what we have done is we have created an instance of student class and we name it as mark, and then to this instance we have created or we have assigned some values, and these values we can access these values with the same names, mark.id, mark.name and mark.age. So you can just write sys o control shift, and then you can just write mark dot name is so you use plus or concatenation operator is, and then plus, and then mark dot age. So we will print mark is whatever his age is, years old. Okay, years old. Okay, and when we run this program, it will print mark is 15 years old. Okay, in a similar way we can create different instances of our classes, and so what we can do is I will just copy the same mark student class, and we will create a new object called, this time we call it Tom. Okay, so here Tom is the second instance of the student class. Okay, and his id is 2, name is Tom itself, and the age is for example 14. Okay, so in here we can once again make the copy of this print line method, and this time we will just replace mark by Tom, and now you can see it prints Tom is 14-year-old. And is there something wrong here? Yeah, here we haven't changed this instance name here. Okay, once again we will run the program, and it says Mark is 15-year-old and Tom is 14 years old. Okay, so using a class we can define different object, and we can define these object values of object member variable values which are independent of each other. So this instance values, which are id, Tom's name and Tom's age, is independent of Mark's id, Mark's name and Mark's age. Okay, so this is a very important property of object, that it can store its own state and it's independent of the other instance, right? Now in in Java programming or programming in general, we never use, or this kind of usage, direct usage of variables are discouraged. And why it's discouraged? Because any other person or whoever is whoever is using your code can modify these values. So we use some some methods or some functions which can get or set these values. Okay, so what I mean by getting and setting these values is uh, I can go to this class called student, and in here I can just go to the source tab, and in here I can go to, so we will go to the source and just go to generate getters and setters here, and here we can see operation is not applicable in current class. Okay, and in here we will just use this and click once again getters and setters. So just click one variable name or variable, then only this will work. So go to source once again and create getters and setters, and in here select all. So we are basically making getter and setter method for every value, because we don't want to use or we don't want to access these variable directly. We just create getters and setters for all of them, and whenever we click OK, you can see here Java has created us these getters and setters for all these values. Okay, and what this is basically doing is, it has, we whenever we want to assign some value to the id, we will use set id method, and whenever we want to get the value of id, we will use get method, and this is called encapsulation of a variable. And this is important because we don't want to give access to our variables to some other user which is unknown to us, right? And so now what we are going to do is, we have generated these getters and setters in between our variables, so we can just cut these values and paste it here, and these getters and setters we have generated for all the values, right? So now when we want to assign some value to the mark instance, instead of this mark.id, we will just use mark.set id or set id, and then we can give any id to mark, and this value assignment is we are not going to use. In the same way, we will use marks dot set name, and this name we will give to mark, and in the same way we will assign age to mark. So mark dot set age. Okay, age is 15, right? And in the same way we will do something with Tom's instance also. So Tom dot set id, Tom dot set name. So Tom dot set name, we will assign this name to Tom, and Tom dot set age, same thing here. So basically what we have done, we have used, instead of a direct assignment, we are assigning values using these getters and setters, and this protects your data from corrupting if somebody wants to corrupt your data or something like this. Okay, and to get these value, you just call mark dot get name and mark dot get age. Okay, and same we will do with our Tom instance, and whenever we run the program, result will be same, but This is more preferred while you are accessing or assigning the values to the member variables. So this is how classes works in Java. How to use a class constructor and what is a class constructor. So first of all, we will start our tutorial by making a new class. So I will go to my package and I will right click and go to new, and I will create a class and I will name my class as cube. By this cube class, I'm going to get, or I'm going to calculate the volume of a cube using different length, breadth and height. So I'm going to declare three variables, int length, int breadth and int height, so that I can calculate the volume using all these three variables. And then I will declare a method which will return int, and I will name it as get cube volume, and this will take nothing as parameter. And what this method will do is I'm going to just return the length, the product of length into breadth multiplied by height. Okay, so this is the volume of the cube, right? Length into breadth into height. Okay, and this was get cube volume, right? So I have declared this class. Now I'm going to initialize an instance of the class. So I will create a cube and I will name my cube instance as cube1 is equal to new cube, right? And this cube with the round bracket is called the constructor of your cube class. And the most basic property of constructor is, even if you don't define a constructor, Java will create a default constructor for you whenever you create a class. So we haven't created this constructor method explicitly anywhere here in our class, but this is default constructor which is provided by Java for us. And we can also define a constructor for us, and the constructor name is always exactly the same as the class name. So for defining a constructor, you can just write cube, and it, for default constructor, I'm not going to pass any values right now, but it can take values, okay, or parameters. So here you can provide parameters as you can do it with the method. But the most important property of constructor is it has the same name as class and it never returns any value. So constructor never returns any value. So you cannot return like this in constructor. Okay. Now what I'm going to do is this constructor, let me print something. So sys o, and I'm going to print we are in constructor. Okay, and in our main class, in our main method, we have just defined the instance of this cube class and nothing else. And when we run the program, it prints we are in constructor. That means whenever you create an instance of a class, the first method which is called or which is initialized is the constructor of the class. Okay, so you can define a constructor, and if you want to initialize something, you can do it with the constructors because it's the first method which will be executed, right? So constructors are generally used to initialize values in a class. So what I'm going to do is I'm going to initialize some value like length is equal to 10, variable breadth is equal to, for example, 20, and variable height is equal to 30, for example. Okay, so this is the default constructor we have defined, and in here we have defined the value of length, breadth and height, so that if user even don't initialize these length, breadth and height, we are going to initialize, or Java will initialize this value for us using this default constructor. So now what we can do is we have initialized the instance of the constructor, and using this constructor we can print, or we can call get cube volume method. Okay, so not here but here, cube, which is the instance of this cube class, dot get cube volume, and this will return us the product of 10 into 20 into 100, which we have initialized these values as, right? Now you can provide multiple constructors or constructor overloading to the class. So you can provide this constructor, which we can consider as a default constructor, and in here we are going to provide three parameter, int L, comma int B, comma int H. Okay, and these parameter we will pass to our length, breadth and height. Okay, so this is called constructor overloading. So we can define two constructor at the same time, both with different pair of arguments, and this we will call it as default constructor, and whenever you want to provide some values by yourself you can use this constructor, right? So what we are going to do is we are going to define second instance of cube class, cube 2, which is second instance, is equal to new cube, right? And now we can just call the same method get cube volume, but using cube 2 instance, and here we will define length, breadth and height, for example 20, 20, 20. Okay, so Java is intelligent enough to understand that this constructor is this one, and whenever you don't provide any argument, whenever you hover over your constructor and just control click it, it will go to the default constructor here, right? So now when we run the program, one will give us the product of these values 10 into 20 into 30, which is 6000, and other will give us the value of, or product of these value 20 into 20 into 20, which is 8000. So we can define multiple constructor with different argument as we require with our class. Okay, so this is all about constructor, I think. And once again I'm going to review what are constructor. Constructor are the member method in a class which have the same name as your class, exactly the same. Constructor never returns any value. Constructor can take parameter, or they cannot, you can, it's totally on you if you want to provide any parameter to a constructor or not. You can define multiple constructor and use them with the class. So I have defined constructor with no parameter, so I can define it like this. And I have defined a constructor with 3 parameter, length, breadth and height, so I can define it by like this. Okay. In this video, we will learn about method overloading. In the last videos, I have shown you how to use a method. Now, method overloading is same as declaring method, but the main thing is you can define different method with the same name. So, two method you can define with the same name which can perform two different different logic. So for example, I want to add two values and I want to declare some method for this. So I will declare a function called public static, and it will return integer value, and I will name it as add. Okay, and what it's going to do is it's going to add two values. Okay, and it will return these two values, and then I will pass int a comma int b as the parameters, and I will return the sum of these two values, right? A plus b, and I can call it in here, right? But in real world programming, the situation may occur that you want to add not only two integer values, you may want to add two double values or decimal values, or you may want to add two strings, because plus you can be used as a concatenation operators also. So what you can do in Java is you can define the method, two different method with the same name, but for example different parameters and different values. Okay, so you can define add something like this, or you can define add something like this, and this is called method overloading. Whenever you define different method with the same name which performs some different logic, but they have, the same name, they can perform mostly same logic, but data type you want to use them or parameter you want to pass them can be different. And whenever you will call these method, for example something like this, you want to add two values, you can just call add two integer 1 comma 36. So it will by default Java knows that whenever you pass two integers here in a method, you are calling this method because you are passing two integers. In the same way, whenever you pass two double values, for example 5 point something and 40 point something, then your Java program knows that you are calling this video. So Java is intelligent enough to deduce your method by your initialization of the method. In the same way, you can pass whenever you want to pass two names, for example hello and second parameter as world, then also it it can know that you are calling this function because it takes string values, and whenever you run the program it will give you different result. And so in the first case this add is calling this function, in the second case this add function is calling this function, and in the third case this add is calling this function. So the method overloading, or the basic logic of method overloading, is you can define different method with the same name to perform different operations, okay, but logically they will be doing some same kind of work. And in this video we will see what does the static keyword do in a class. So in the last videos which I have been showing you, you may have seen the usage of this keyword static with some member method or member variables of a class. And you may be curious, what is the meaning of this? This is not just we are putting like this. It has some meaning. So the meaning behind the static keyword is, whenever you declare your member as static, the static member belongs to the class instance instead of some specific instance of a class. So let me give you an example and then we will see it once again. So I have a class called hello, and which contains two methods. One is a static method and other is a non-static method. Static method means I have added static keyword to this, and this method is not doing much. It's just taking string as an argument and it's returning this string in as whatever we pass back. And the same method we are using here, it has a different name which is do something else, and this does not have any static keyword in it, okay. So whenever we declare the instance of a class, for example hello is equal to new hello, the static member is shared by, so whenever you create an instance, you can create many instances of, for example hello 1, hello 2. The static member method will be shared by every instance, okay, and the static member only belongs to the class, not to the instance. So it will not belong to the instance of a class, but it will only belong to the class itself. So if you want to do something like this, say dot do something, which is a static method, and we want to pass some message, hi YouTube, for example, it will work, and it will work fine, but it will give some warning here, and the warning is the static method do something from the type hello should not be accessed in static way, okay. So you cannot access, or you can access this, but it's a wrong way of accessing this method, which is declared as static method. So for accessing your static method, whatever you define as static, you can access this method directly from a class like hello dot do something, and this is the right way. And once you do this, your warning message will be gone, okay. But a non-static method, when you try to access, so this hello is my class name, dot do something is not, something else is not available in this class, right. So this method is not available or cannot be accessed directly with the class name. But whenever you add a static before your method name or variable name, it's accessed from the class itself. So do something is accessed from the class, and do something else, which is not a static method, cannot be accessed by directly by this class. You see there is no do something else. But this non-static method is available through the instance of a class. Okay, so basically the non-static methods are available or can be accessed using the instance of a class, and the static method should be accessed using the class itself, not the instance. Okay, so this is the correct way of using a static class or static method, and this is the correct way of using non-static method. You can even declare some variable as static, for example public static int age, for example, and then whenever you want to access by this instance, you can just for example hello dot age. Whenever you want to assign some value to the age, let's see what happens. So it's okay right now, but it's once again showing the warning that the static field hello age should be accessed statically, right? Once again we define a different instance of this class hello1, and we assign some different value here, for example 20 or 50, right? And we will print hello age once again. So sys o, and we will print this hello age here, and we will print this hello age here also with this instance. Okay, and for now let's comment these two, and when we run the program it gives you the same, I mean the answer, but it's preferred because it's a instance, or not the instance, but it's the X member of the class. You need to use it like this, not by instance but using the class itself. Okay, so whenever you want to declare a variable or a method static, just access them using a class, and whenever you are using non-static method or variable, access them with the instance of a class. Now in this video I'm going to give one more example, so this uh, meaning of static will be more clear to you. So for example, I have a class called student, and in this class I have two member variables. One is the name of the student, which is a string, and one is the age of the student, which is an integer. And I have made the getter and setter functions of this class variables. Okay, so if you don't know how to make these getter and setter function, they can be made automatically. So just go to your class and go to source, and in source you will be able to see here generate getter and setter, and in here just select all and click OK, and your getter and setter method for age and name will be generated automatically by Eclipse for you. Okay, so now what I want to do is I will declare a static member variable which will be int, and this variable name I will say is the number of students. Okay, and whose value is I will initialize as 0. Okay, and I want to keep the record of number of students, and I will make it as, or I will declare this as static, so that it can be shared by all the instances. Okay, so static. So it's a static member. Okay, and now I'm going to define a constructor which is same as the name of your class, student. And here, whenever this constructor is called, I want to increase the value of number of student by 1. So whenever somebody makes or initialize a student class, I want to increase the value by 1 so that we can keep the track of number of students, right? And for this we are going to make a function to get the value of number of student. Okay, so we are going to make a public function, public int, and I will say get number of students, and this basically is going to return the number of student, which is this variable, right? So number of students return. Okay, so whenever we call this function, let's define this function also as static function so that we don't need to call it by any instance. We can call it by the class itself. Okay, now we go to the main class, and in here we are going to define some instances of this student class. Student, for example, Mark is equal to new student, and once again student Tom is equal to new student, right? And now we are going to call our get number of student, because whenever this constructor is called, we are increasing the number of student by 1, right? So now we will just write sys o control shift, and in here we will call the student class itself, because it's a static member function. This is, so we can directly call it with the class itself. We don't need to use any instance, right? You can use instance, but it's not necessary. Okay, and when we run the program, you see the answer is 2, right? So it's shared by your instances. So this member variable can be shared by your instances, and to verify this, we can call this member function using instances also. Okay, so for example, when we add Mark instance and when we call this get number of student by Tom instance, then what is the value of the number of students, right? So run the program, and it says first time when we add first student, its value is 1. That's right, because when we added the first student, the number of student will be 1, and when we added second student, the number of student will be 2. So this member variable, which was static, was shared by both the instances, and also this can be called by the class itself, right? So this is the very basic and important property of static member, that it can be shared by the instances also, and you can call it using your class itself. In this video, we will see what are access modifiers and how we can use access modifiers in Java. So you may have seen the use of public whenever I define some class or some method in a class, and this public or private, or this can be protected These are called access modifier. And what access modifier mean is it basically allows you to access this method or whatever class in a package. Depending upon the keyword or access modifier, we can access it inside the class or inside our package or inside whatever inside our project. So how we can grant the access and what keyword means what, we will see now. Okay, so basically we have three kinds of access modifier. One is called public, other is called protected, and third one is called private. And if you don't give any access modifier, for example, I haven't given any access modifier to this string name and integer age, this will be visible, or we can use these variable inside the package and inside the class. So because my class, which is this one, and student class are in the same package, I can use these inside here. So let me delete these, we don't need them anymore. So my class and student class are in the same package. See here, in lesson 1 we have my class and student class, right? So if you provide no access modifier, public, private or protected, they are visible in the class itself and the package. So package, inside the package we have this class also. So we can define an instance of the class, for example student stu is equal to new student, right? New student. Okay, and whenever we want to access this stu dot, and this name is available, name and age both are available in this class also, right? Because my class, which is this class, and this class, student class, are in the same package. Okay, so basically this is what we are doing here, or we mean here. Okay, and name should be some string, so something like this, right? And when we compile the program, we will not get any error, right? So whenever we give public access modifier before any variable, for example I give public before my name and the age variable, it's visible everywhere in your class, in your package, in your subclasses. We will see when we see how inheritance work in Java. And basically if you define a variable as public, it's visible everywhere, right? But it's a good practice to not give access to your variables to outside your package or even outside your class. Okay, so the good practice is always declare your member variable as private or protected. And the basic logic behind this is you don't want that your variable should be affected by any other user. Okay, so you give indirect access to your variable using getter and setter functions. Okay, so whenever you add this private access modifier before your variable name, it's only accessible through your class itself. So outside your class, outside this student class, you cannot access if this member variable is private, right? So now whenever I try to run the program, I will get an error, and the error will be, I will go to the error and it says the field student name is not visible. It's not visible because we have declared this name as a private member of the class. And whenever we declare private member of a class, it only is very visible inside the class and not in the package, not in the subclass, not anywhere else. Okay, so there is other keyword called protected, which we will see when we learn about inheritance and other things. But protected also restricts the visibility of your variable in the class itself, package and subclass. Okay, so right now we are not going to discuss more about protected, because this protected we will use whenever we are going to learn inheritance and polymorphism, right? So right now just remember this table or memorize this table. Whenever you declare your variable as public, it's visible everywhere in your class, package, subclass, or anywhere else. If you declare your variable as private, it's only visible in your class and nowhere else. Okay, n means no here and y means yes here. Okay, and it's a good practice to make your variable private so that anybody else should not have the direct access to your variable. And now, so we cannot access this name directly from here. So how we can allow the user to set the name of the student? It's easy, by using setter and getter function. So go inside your class, just click anywhere inside your class and then go to source and click generate getter and setter. Okay, generate getter and setter, and Java will automatically generate getter and setter for you, whatever you check. If you want to want getter and setter for name, if you want getter and setter for age, you can check both of these. So I select all like this. I can deselect all, and for now I am selecting all and click OK, and it's created 4 methods for me. First one is get name, which just returns the value of name. So indirectly we are accessing the value of name, but not directly, right? And set name allows you to set the name, but not directly, but using the copy, right? And in the same way we have defined the getter and setter for the age. And by the way, if you are wondering what is this keyword mean here, so whenever you see this name and this name is similar, and whenever you define any variable inside a function, for example this name will be preferred. So whenever you want to do something like this, Java may get confused. This name is this name itself, or this name which you define in the class. So this keywords tells Java that it's a member of the class, which is this one. So this indicates class itself. So this means whatever class we are in. Okay, so student.name, which is this variable, not this variable, right? So basically you need to use, or you can use this keyword here whenever you have 2 variable with the same name and you want to differentiate between them. This dot whatever is the member of the class, which is this one, and the variable which doesn't have this is the local variable. Like, so the name here is the local variable, this one, and this name which is preceded by this is the member variable, this one. So this is what this means. This means the class itself, student.name. Indirectly you can say, instead of this you can just imagine it like student.name. Okay, but this keyword indicates the class itself. And now if you want to set the name, what you can do is, instead of directly setting the name, you can just write stu.set name, and then you can set name like this. Okay, and whenever you want to get the name, you can just do something like this: instance of a class dot get name. Okay, so this will allow you the access to this variable name, but indirectly. Okay, so just remember this table. If you can memorize, public grants you access to everywhere, private grants you access only in the class itself. And it's always the better practice to make your variables private unless and until you have the strong reason to make them public, and use getter and setter to access these member variables. Okay, and the meaning of this is the class itself. So if you add this keyword before any variable, it means the member of the class, and whenever you don't have this here, then it means it's a local variable. So you can avoid conflicts between two similar variable names. In this video, we will see what does final keyword do in Java. So for example, I have a class called hello, and I define a variable public final int number, and I have added final to the variable declaration. What does this final declaration do in front of any variable declaration, or in front of class declaration, or even in front of method declaration? They have different meaning whenever you add it with the variable or a method or a class. So let's see what does this keyword mean. So the final keyword has numerous way to use. When we use final keyword with a class, this class cannot be subclassed. When you use final with a method, this method cannot be overridden by a subclass. And when you use final with a variable, it can only be initialized once. Okay, so first of all, we will see this point, that if you declare a variable as final, it can only be initialized once. Okay, so I have declared a member variable which is public final int number, and what's here written, it can only be initialized once, right? So for example, I declare a constructor with the same name, and I'm going to initialize this value in my constructor. So number is equal to 10. Okay, so I have initialized it only once, right? Now I will create an instance of this class in my main method. Hello is equal to, or hello hel is equal to new hello, and what I'm going to do is I will try to assign the value to this number hello dot number once again, right? So for example 20. Okay, and when I run the program or compile the program, it gives me error, and the error says the final field hello dot number cannot be assigned, right? So once I assign this variable which is final, then I cannot initialize it once again. Okay, so if I comment this, this will compile perfectly fine. So it has compiled perfectly fine, but if I try to reinitialize or reassign a value to a final variable, then it's not allowed. So generally, you whatever value or whatever variable you want to declare it as a constant, you can add final keyword before this. Okay, now the first point, the final class cannot be subclassed. When we will learn about inheritance, we will also learn about what is subclassing. And what this subclassing means is you can have the properties of one class into another class by the means of inheritance. So for example, I have the student class, which whose property I want to use it, or property or member variables or member method inside my hello class. I can use it like extends and then student class, not this one but student, not this but this student, right? And this is totally fine. If you write extend student, this means that we are inheriting from student class to hello class, and this inheritance we will learn in the further video, but I want to show you what this final keyword mean, right? And when we compile the program, it will give us the error. And what is the error? Final cannot be initialized. Let's comment this and then once again compile the program, and it compiles totally fine, right? Because student class is not final, right? So if you add this final keyword before the declaration of a class, for example, I will write public class student instead of public class student, I write public final class student, final class student. So I have made this class as final, right? So if I made this class as final, now see what happens. It shows whenever I compile the program, it will show error. And what is the error here? The type hello cannot subclass the final class student. Okay. So whenever you declare a class as final, you cannot subclass it from it. Yeah. Okay. So you cannot extend from that class. Okay. And the point in the middle, that the final method cannot be overridden by the subclass, this we will learn when we learn how to use inheritance and how to use overriding in a class. Okay, so just remember these three key sentences and you will be good to go. And in this video we will see what is class inheritance in Java and how to use class inheritance in Java. So classes in Java can be extended, and how they can be extended? By creating new classes which can retain the characteristics of the base class. And base class, I mean here, is the class from which we are inheriting. Now, to understand it fully, I have a little diagram to explain. Now, for example, I want to make a class which can calculate the area of some shapes. So it can be rectangle, square, circle, or triangle, or anything, right? So I can make a class called polygon because they share, rectangle and triangle shares a similar property. And what is this property? They both have width and height, right? So I can define two variables in my polygon class, and I can set these width and height of these value in this polygon class using a method setValue. And in this rectangle and triangle class, I can create two methods which can calculate the area of triangle and area of rectangle. So the common properties which they both share, which is height and width, we don't need to define it in separate places in rectangle also and triangle also. We can define them at the single place, and we can use them using the inheritance property. And how you can know that these shapes or whatever classes you are going to make shares a inheritance property. So if the classes you are making have is a relationship, is a means, what I mean to say is a relationship, like this. So rectangle is a polygon, right? And triangle is a polygon. So they share is a property in between them. So this relationship, whenever some class inherits from some other class, they share is a property or relationship. So rectangle is a polygon and triangle is a polygon, right? So let's go towards the code part of it. So what we are going to do is we are going to make three classes. So we will go to the package, one class, first class we are going to make, and I will call it as polygon, right? And I'm going to make two more classes. One is rectangle and one is triangle. So I will say this is rectangle class, and I'm going to make one more class which is going to be the triangle class. Triangle. Okay. Now in my polygon class, I have what property in common? Both rectangle and triangle can have width and height. So I will define two variable which will be protected. And why they are protected, I have shown you, and I have shown you what is the meaning of access modifier. So protected, and then int height, and in the same way I will declare one more variable which will also be protected, which will be width. Okay, and I will define a method which will be public and which will return the area. So for example, we will return area in double, right? And so this in here, let's try to set the values of width and height for rectangle and triangle. Okay, so this will be void set values, and in here we will define int a comma int b, and whatever user will pass the value of a, we will just say height is equal to a and width is equal to b. Okay, so by this method we are going to set the values. Okay, now in my rectangle class, how we can inherit from this polygon class? We can inherit from polygon class in my rectangle class by using keyword extends. Okay, just use the keyword extend and then use the class from which you are extending. Okay, so rectangle class is inheriting from your polygon class, and polygon class is in here is called derived class, and rectangle class here is a class which is deriving, right? So this can be called base class, and this can be called the class which is deriving. Okay. In the same way, I will extend in the triangle class also from polygon, because polygon is my base class from which I'm inheriting. And now in my rectangle class, I'm just going to calculate the area. Now whenever or if you are inheriting from a base class to a derived class, then all its protected members and public members are accessible in your derived class. Okay, so these member height and width and set values are accessed, can be accessed by this rectangle class because we are extending from it. Okay, if this was these variables and this methods was private, then we cannot use them in other classes. But because they are protected and public, protected and public method can be used in subclasses. So this is a subclass and this is a base class. So we can just define a method public, and this will be the area. So double area, and what this method is going to do, it will just return the area. So return height into width. And which height and which width we are talking about here, because we haven't declared width and height inside this class, in this rectangle class, right? But whenever you hover over and click on this height, you will go to the height in polygon class. Okay, so this height in polygon class is accessible in this rectangle class also. Okay, and width also from polygon class is accessible in the rectangle class also. Okay, in a similar way, the area of the triangle is half, so height into width divided by 2, right? So we will just divide it by 2. Okay, so we have everything. We have the area of triangle, we have area of rectangle, and we are setting these value via this polygon class. Now what we can do in our main method, we can use, or we can create the instance of rectangle class. So rectangle, rec for rectangle is equal to new rectangle, and we are going to create the instance of our triangle class also. So triangle tri is equal to new triangle, and then for calculating the area we first need to set the value. So we will set the value of first rectangle. So we will use instance of rectangle class dot set, because we are inheriting from the polygon class in rectangle class. This set value method is also accessible in the rectangle class via its instance. Okay, that's why we can access set value method via this rectangle instance. For example, we have 10 and 10 width and height. Okay, in the same way we can access set value method from our triangle class, and this for example is also same 10 and 10 width and height. Okay, now we just need to call the area. So we can just write sys o, and from rectangle class we can call its area method dot area, and in the same way, we can call the area from the triangle instance, which is tri. And now when we run the program, we will get the answer. First is the area of rectangle, and second is the area of triangle. So we can just modify this something like this: area of rectangle is equal to plus, right? In the same way, we can write area of triangle is equal to this one, okay? And area of rectangle and triangle are displayed like this. Area of rectangle is 100, which is 10 into 10, width into height, and area of triangle is equal to 10 into 10 divided by 2 is equal to 50, right? So once again, whenever we use inheritance, all the property of the base class, in our case polygon class, is available in your derived class. In our case, these are rectangle and triangle class. So all the method which are protected or public are accessible inside our rectangle or triangle class, okay? So you can use the method inside polygon class. If you derive it in rectangle class, you can use this height and width we have derived in here using this rectangle class, because we are extending from it, okay? So in this way, you can extend the property of polygon class to the rectangle class, and same is for triangle class. And in this video, we will discuss what is polymorphism in Java and how we can use polymorphism in Java by an example. So what is polymorphism? Polymorphism is the ability of an object to have different form. So polymorphism literally means, the word polymorphism means having different forms. And whenever you define an object, class object I should say, and its property or its quality of having many forms is called polymorphism. And how we can make our classes polymorphism, or how we can define an object which follows polymorphism, I'm going to give an example. So I have 4 classes defined. One is called the bank class, which will be my base class, okay? So there is a bank class which is my base class, and this contains 3 or 1 method, and this method just gives the rate of interest. So I define this method as get interest rate, and because it's a base class, I'm returning 0 as an interest rate, okay? I also have defined bank underscore ABC class, bank underscore DEF class, and bank underscore XYZ class, okay? So if you don't know how to make a class, just right click new and go to class, and in here give the name of the class. So this is how I have created these classes, okay? So one is called bank class, which will be my main class. Second class is called bank underscore ABC, which extends from bank class, because bank class is our base class and bank ABC is our derived class. And this also contains the same method, but this returns the rate of interest, or this bank has a rate of interest is equal to 5%, for example, okay? Bank DEF, which also extends from bank class, have the rate of interest 6%. So I have defined a method here which returns 6 simply, okay? and bank class XYZ, which is also extending from bank. So this is a derived class and this is a base class, also have the same method, get interest rate, and the interest rate in this bank is 10%. So I have the same method in all the 4 classes, get interest rate, and the only difference between this function is the rate of interest. Bank itself has 0, bank ABC has 5% interest rate, bank DEF has 6% interest rate, and bank XYZ has 10% interest rate. Now there is a property in Java called polymorphism, by which you can define the reference, or you can point the reference to a base class to any object of the derived class. So what I mean by that is, so when a reference object or reference of parent class points to the object of the subclass, it's called upcasting, and this is the basic extract of polymorphism. So we will define the reference of our bank class. So we will just define bank B1 is equal to, or bank ABC is equal to, so this is the reference of bank class which will point to the object of bank ABC, which is a child class, right? Like this. And this is what we call polymorphism. When an object can have different form, so here the object of bank class is having the form of bank ABC, right? So the reference of bank class is pointing to the object of bank ABC class. In the same way, we can define different objects. So here we can define bank DEF, and here also bank DEF, and bank XYZ, and bank XYZ. Okay, so, and let's see if it has the same name or not. Yeah, and bank XYZ, it should be underscore, right? Okay, so we have defined 3 references of bank class itself, which points to the subclasses or object of subclasses. Reference ABC points to the object of bank ABC class. Reference DEF points to the reference or object of DEF class, and reference XYZ points to the object of XYZ class. And I can call all these method get interest rate from all these references, right? So I can just write sys o control shift, and in the same way I will do it 3 times, and first time I will take ABC as my object and I will just call get interest rate, and in a second statement I will paste DEF dot get interest rate, and third time I will paste XYZ as my instance and I will call get interest rate. Okay, and when I run the program I get 5, 6 and 10. So this type of reference, defining reference from the object of subclasses, is called polymorphism, and all the member function are available through this reference. So this get interest rate are available in here, in this class also, in this class also, in this class also, and this bank ABC gives us 5% interest rate, so it returns 5. Bank DEF gives us 6% interest rate, so it returns 10. And bank XYZ gives us 10% interest rate, so it returns 10. But the interesting thing here is all are the object of bank. Yeah, all references are pointing to different objects, but all objects are from bank class, right? And in this video we will see what is method overriding and how it's different from method overloading. So in the last video I have shown you how and what is polymorphism and how we can use it, right? So we have defined a superclass which we call it as a bank, and it was having one method called get interest rate, which returns the interest rate of the bank. Okay, and we have defined a subclass which we call it as bank ABC, which extends from bank class. And let's say for now it doesn't have anything, so it doesn't have any implementation. And now whenever we create the instance or the object of class ABC using the reference of bank ABC, or using the reference of bank class, which is our superclass, then what happens? Let's see. So it returns you 0, right? Because here in the superclass it has the method get interest rate, and which returns 0, and here there is no implementation of get interest rate, right? So whenever we define a reference which points to the object of the subclass, which in our case this is bank ABC, and when we call this get interest rate function, it refers to this function which is in the superclass, right? Now for example, we introduce a function which has the same name and same return type and same number of arguments as in base or superclass. Okay, so I have the same implementation in my subclass also. The only difference is it's returning 5 and our superclass was returning 0 interest. Okay, and now earlier the interest rate returns was 0, and now when we run the program it returns 5, and this phenomena is called method overriding. And method overriding is nothing but the changing of the implementation of the method. Okay, so earlier the method which we were using for getting the interest was this one, get interest rate from the base class. But as soon as we introduce a new method in a subclass which is same and it's returning different interest rate, and we define the object of the subclass as a reference, then you see it's returning 5, right? So your base class or your object will always take the latest or the most recent method which is defined. So this is the most recent method, and it's happening at the runtime. That's why it's returning 5. So this is called method overriding. Now there are some rules for method overriding. The rule of method overriding is you must have same number of arguments, same name, and same return data type for overriding a method. So for example, this get interest method was returning integer and it doesn't take any argument. In here also we have to, whenever we want to override the method which was there in the superclass, we have to define the integer return type and with no argument. if you do it something like this, int for example this thing, this will be called method overloading, and this will not be called method overriding. So this takes us to what is the difference between method overloading and method overriding, right? So generally method overloading we use in a same class, right? So in this, if we want to do it, we can do it something like this, and we can return int abc, something like this, okay? And this two method are called the method overloading. So this method is overloading our previous method, right? So this generally happens in the same class, and whenever you do the method overloading, this return type can be different, the arguments can be different, but the only same thing here is the method name. So in method overloading, only method name should be same, but you can change the return type or number of argument also. But in the method overriding, you cannot change the return type or the number of argument, okay? So this is the main difference between method overloading and method overriding. So I hope you have understood the basic concept of method overriding and what is the difference between method overloading and method overriding.
And in this video we will see what is an abstract class and why and where we will use abstract classes in Java. So what is an abstract class? An abstract class is a class which cannot be instantiated. So for example, if you make some class as abstract class, you cannot make an object of this class. And what is the reason behind this is, for example, I have been showing you this bank class in the last two videos for showing the polymorphism example. So I have this superclass called base bank, which is my superclass which contains a method, and I have a subclass which extends from my superclass, which is inheriting this superclass, and it also contains a method, okay, which is get interest rate. Now a bank is abstract in a way that bank is a general term, or we can say bank itself is very abstract word, because we cannot deduce which bank we are talking about from this class bank. But we have bank ABC which have some name, and this can give you some interest rates or whatever other facilities which can be related to the bank, right? So in a way, this bank class is serving as an abstract for other classes. So it's just facilitating to the other classes its method or member variables, okay? So for example, we don't want this class to be instantiated, we just want that this class should be used by the other classes to have its functionality. For example, we can add some more function to the abstract bank, and we can add those method, or when we can use those method using the inheritance property in our subclasses, okay? So bank is a very abstract class, and these kind of class, sometimes we don't want the other user to make and make the instance of this class, because whenever you make the instance of the class, the interest rate here, for example, we are returning 0, which means no interest, right? So whenever we make an instance of this class like this, and when we run the program it gives us 0, which doesn't really mean anything, right? So if we define this class and abstract, so how to define a class and as an abstract class? You just need to write abstract keyword before your class. So this keyword, when you add to a class, it makes your class abstract. And as soon as you add this keyword to your superclass, which is a bank, you see here that this object creation is not possible anymore, because this is the basic property of abstract class, that you cannot create any object from the abstract class, but you can create a reference from its subclasses. Okay, so you can create a reference which points to the subclasses, because bank ABC is not an abstract class. So you can use this bank ABC like this, okay, and this error will be gone. Okay, so you can make a reference which points to the class which is not abstract, but indirectly this bank class is an abstract class which cannot be instantiated, or we cannot make an object. So indirectly we are restricting the access to this class from other users. Now we don't even have or we not only have abstract classes, but we also have abstract methods. And abstract method, whenever you define a method as abstract, this method should be implemented by the subclasses which is inheriting the class. Okay, so there are two conditions to make a method abstract. One is the method wherever it's present. So this method is present in my bank class. This class should be abstract to make this method abstract. So we can make this method abstract, and whenever you make a method abstract, you don't need its instantiation or definition. So the most basic condition is the class in which this abstract method is present, this should be also abstract. So the class should be abstract, then only you can make a method abstract. And whenever you make an method abstract, you need to give the implementation of this method in your subclasses, because bank class is our superclass and bank ABC is inheriting from our superclass. We need to give the implementation of all the abstract method which are present in our abstract class. So we need to give the definition of this method in here. So whatever classes which are inheriting from this, you need to give the definition here, here, and here. For example, I just comment this in this method, bank ABC method, which is extending from the bank class. Then this class will give the error that the type bank ABC must implement the inherited abstract method, right? So you cannot compile a program if you don't implement the abstract method in the subclass. Okay, so if you make any method abstract, you need to implement it in your subclasses if you are inheriting from this class. So this is how abstract classes and abstract method works. The other thing is you may encounter a keyword called concrete, and the concrete class is literally or almost opposite to the abstract class. So if the abstract class cannot be instantiated, the concrete class can be instantiated. And so this class which is inheriting the abstract class, we haven't added abstract keyword here, but we don't even need to give concrete keyword in order to make it concrete. You just need to you don't need to give anything. You just need to give public or private or whatever class you want to declare, and this makes your class concrete. So if you don't add abstract keyword before a class, it's concrete because it can be instantiated. And if you add a keyword abstract before a class, it makes the class abstract, which cannot be instantiated. So I hope you have understood the basic concept of abstract and concrete classes.
And in this video, we will see what are interfaces and how we can use interfaces in Java. So an interface is same as an abstract class. As abstract class cannot be instantiated, an interface also cannot be instantiated. So for making an interface, for example, we have been seeing this example from our last videos, and we have a bank class which is our super class, and when we define this class as an abstract class, this bank class cannot be instantiated. We have seen in the last video. Now, in place of doing so many things like declaring abstract public class, we can just use a keyword called public interface, and then it makes your interface something like this. And all the method inside an interface are abstract by nature. Okay, so you don't need to add a keyword abstract in any member method of the interface like this. All the method or all the members of the interface are abstract by nature. So in the last video, we have seen if the methods are abstract, then we need to implement this in the subclass in which we are inheriting, right? Now let's start from the beginning. So I'm going to delete all the classes which I made earlier, and then I'm going to make an interface. Okay, so in Eclipse you can make interface by just going to the package in which your main class is or main method is, and just right click it, and you can just go to new and click interface here, and you can give the name to your interface. For example, we will give the name to our interface as bank, as we have given in the last video to our abstract superclass. Okay, so this is the basic definition of interface, and whatever method you define inside the interface, like get interest rate, it's automatically abstract by nature. Okay, so whenever you want to inherit from the interface, so interface only can be implemented, not can be extended. So when we define a class, for example, we will define a new class for bank interface, and this class we will name it as bank ABC, for example, and we want to inherit from the interface. This interface, because this is an interface, there is no class keyword in here in the bank interface, right? So you cannot extend from interface in a class. You need to implement the interface, so you need to use the keyword implements. something like this. Okay, and then you can implement your bank interface and you will be good to go. Now, because we have this get interface or get interest rate method inside our interface, we need to define or give the definition of this get interest rate in our subclass also, because all the methods inside our interface are abstract by nature, right? So you need to give definition something like this and return some interest rate, and then your definition will be okay. Now it says you cannot reduce the visibility, let's say by, because this should be public by nature, so we just need to add public keyword and then it's okay. So whenever you want to inherit from the interface, use the keyword implement rather than extends. Okay, and whenever you want to inherit from the interface to an interface, you can use the keyword extend. So just bear in mind, whenever you have two classes, class and class, and both are you want to inherit one class from another, then you use extends. Okay, if you have interface as a base class and you have class as a subclass, you need to use implements. And if you have two interfaces and interface and interface, then you can use extend. Okay, so simple rule is, if the both subclass and superclass are classes or interface themselves, both are same, you use extend. And if the superclass is interface and subclass is your class, then you use implement keyword here. Okay, so this is how you can use interface, and interfaces are abstract by nature, so they also cannot be instantiated. So if you want to instantiate bank something like this is equal to new bank, it's not possible because it's just an interface, and interfaces are abstract by nature. Okay, so this is how we can use interface in Java. I hope you have enjoyed this video. Please rate, comment and subscribe, and bye for now.